this computer. My. Ah, sorry about that. I
Never
started
mind.
recording right now, but yeah, it never hurts to have a bit of a backup, right? And
Hmm.
and why am I telling you this story is because we lived in different times, but we had the same problems. We had the same things to be anxious about. I mean, we weren't anxious about our Instagram feed because we didn't have Instagram, but yeah, that was a kind of a reputation you had to uphold, or you wanted to uphold, or whatever. Yeah.
Hmm.
Now, the motor mass of carbon dioxide, obviously, we know it's 44, and carbon dioxide is denser than the average mass of air, which is around 28.
Hmm.
So, if I have an atmosphere of carbon dioxide, that can remain at the ground level, and at higher levels, we may have an abundance of oxygen. This is why, do you enjoy climbing into caves? I have a lot of colleagues who just love climbing into caves.
Climbing into caves.
Yeah, they love exploring caves.
I mean, sure, why not? I don't love it, but I don't have a problem with it, I guess.
Yeah, I'm scared. I'm scared to go underground in an unexplored area because of the carbon dioxide content. I mean, where I'm from, we have limestone. It's called Messerschettig. Basically, it's limestone mountains, and if it comes into contact with acid, it produces carbon dioxide. Carbon dioxide stays down. You may walk around and feel just well. If you're a dude, you're going to feel things in certain places because of the atmosphere of carbon dioxide. It was scientifically confirmed just recently. And if you sit down, yeah, just to drink, you might lose consciousness because you lose air. You
Hmm.
can suffocate just because you sat down in an atmosphere of carbon dioxide. And if you're on your own, that's it. So one has to be very careful. We also had stinky caves. Stinky caves had hydrogen sulfide. Now, the water that came out of these caves was of medicinal use. So do be careful when exploring caves. Only go into caves that have been already explored, and it's a good idea to have a carbide lamp because a carbide lamp goes out if there's no oxygen, and then you know you have to skedoodle
Hmm.
because it's burning. Yeah, the seven dwarfs they used to have a canary. Well, it wasn't just for singing, mind you, and I'm destroying your childhood right there. With Snow White and the Seven Dwarfs. You may have seen these cartoons, yeah? Seven Dwarfs singing with a canary. Do you remember the canary, or is it just my sister's childhood thing? I don't know.
Yeah. I
The
don't.
canary was there to detect if there was no air. If there was no air, the canary would go a little not so alive, or would get really tired quickly, and
Uh-huh.
then they knew they had to go. Oftentimes, miners would also have cats around. For the same reason, because if mice weren't around, then the cat would leave, and if there's no mice around, it means it's an atmosphere of carbon dioxide.
Mhm.
Now again, proportionality for the win. Yep. If it's 3.01, well, how much is it? It's around half a mole, and that should be around 22 grams. Yep. And of course, carbon dioxide will put out a flame. If it's a normal flame, it's a wood flame. If it's a strip of magnesium being lit on fire, it even feeds the flame because
Mhm.
it can just easily reduce magnesium can easily reduce carbon dioxide into just elemental coal. Yeah, it's just really weird. Chemistry can be really weird.
Mhm.
You know that a lot of fire extinguishers do have a CO2 inside of them, and that's the
Yes.
reason why.
Hmm.
Yeah. Now, in the case of various compounds, obviously, you have various structures, and again, formulas are going to define the mass, and one mole of that thing is going to weigh that much, 108 in the case of glucose, 18 in the case of water. I don't think you have any issues with calculating these masses, and stoichiometry and balanced equations, they are law. They make sure that this proportionality exists, right?
Hmm.
I usually make the analogy, oh, it's just like a muffin recipe. And it is. And it is. Did you ever bake muffins?
Of course, yeah.
Yeah, just asking because a lot of boys are really, really bad at cooking. Uh, I have had kids at the Faculty of Health Sciences who were absolutely anti-talents. I mean, one of them got together with a girl because the girl could cook. I'm like, great. I think there were other reasons, but yeah, I think that was a powerful reason as well.
Hmm.
So yeah, that is the most pleasant kind of chemistry because in the end you can lick the spoon. I mean, you can probably do that in other cases as well, but I may not do that. I may not do that. So ammonia forms, and that's the bottom line. And obviously, stoichiometry will make sure that you have the same amount of elements on both sides.
Hmm.
Yep, and the same mass on both sides. So the law of conservation of matter applies.
Yes.
Coefficients are not gram ratios, obviously. Coefficients just show moles, and obviously we can't really read them as grams, and they only apply to the entire molecule. Also, there's a lot of kids from other countries, from other educational systems, who have already finished high school but didn't really learn chemistry nor biology proper. They'll be struggling with this. A lot of them are going to join a college in order to be able to work with natural sciences because for example in Arabic countries, and I'm not talking about Iran. Iran is not an Arab country, but in a lot of Arab countries, oftentimes you have 3 years of Quran studies and 1 year of natural sciences.
Hmm.
So their background in natural sciences is rather to be desired.
Hmm.
So oftentimes they don't really make it to medicine, and all kind of isms come into play. Um, Look, a multicultural and multinational faculty, I don't think would stand for any form of racism.
Hmm.
Why? Because it's not feasible.
Hmm.
First of all, second of all, it's immoral and it's unpleasant.
Yeah.
Be it for or against anybody, because they're like, oh, reverse racism. No, 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 there's just one kind. I don't make a difference because someone is of any background or origin or any looks. Students have abilities, and I judge them on what they're able to produce using those abilities. The language we speak is English. No other languages are to be spoken in class. And obviously, everybody is expected to pull their weight. And when they leave, when they get their degree is also a letter of recommendation, because our university and our faculty should be a letter of recommendation and excellence. We
Hmm.
don't make differences because someone is this or that, even though it is fashionable in quite a few Western countries or East. I don't know. We don't do that. We don't do that here. We
Hmm.
make sure that everybody knows how to calculate, everybody knows how to calculate dosage. And obviously, often medical professionals may have a more limited view of chemistry, not because they don't know chemistry. The chemistry program isn't as stoichiometry heavy and whatnot. It's not like they don't know chemistry. That would be an exaggeration and it would be wrong.
Hmm.
Bottom line is, you won't be studying high level chemistry like the people at pharmaceutical sciences are. And that's perfect because as professionals you will have to work together. Oftentimes, final exams, the practical final exams at the end of uni, are made in a way that various professionals have to work together, just like in the healthcare system, and they're being judged by their professionalism and how they're able to work with others.
Hmm.
So everyone has to do their very best, and it's a more practical type of final exam.
Hmm.
Balanced equations are only going to give us more ratios in naught grams, and that's great
Hmm.
because as chemists, we're going to think in stoichiometry. Oh, the little guy's using the bathroom. I'm thrilled. A lot of my cousins had the same thing. They started talking late and using the bathroom late, and now I'm happy.
Mhm.
Really strange things to be happy about. Have you noticed that girls start talking earlier and doing things earlier than boys?
Yes.
Yeah, I think that's fantastic. There are a couple of work examples. For example, the complete combustion of ethane. Do you like burning things?
Not necessarily.
Well, I didn't say burning property, but you know, lighting a fire.
Sure, why not?
Yeah. But many people are like, not really. But I've never seen anyone being depressed or having ill thoughts next to a campfire. Yeah,
Fair
but
enough.
it can give you a smoky scent. That's definitely true. I
Hmm.
became a chemist because I'm a pyromaniac. Obviously, combusting various proportions of these is gonna lend different compounds. If we would use a clear fraction, obviously, in order to balance the left and the right side of the equation, we will have to take seven of the first, sorry, two of the first seven oxygens, and carbon dioxide and water. The presence of carbon dioxide and water shows me complete combustion. This is what we're looking for. This is what we're striving for.
Hmm.
If your stove is using gas, this is what you're looking for. A lot of locals
Hmm.
they don't really take their stoves for any sort of maintenance, and it is a 60 or 70-year-old stove made in the Austro-Hungarian Empire, for all I've known, and they're complaining that the quality of gas is bad nowadays because the flame isn't blue. Dude, that can be built up. It can be a health hazard. So regular maintenance, regular cleaning by a professional will maintain complete combustion and the flame will be blue and properly hot enough.
Hmm.
So a balanced equation means that for each and every gas mixture that is being used, you need to set your stove
Hmm.
up with the appropriate settings. Now, can you do that at home? In Hungary, it's not advised because we're not professionals. The professionals, they're gonna do it, and then the warranty of the stove will remain.
Hmm.
If it's not installed by a professional, you're voiding your warranty nowadays. Safety is paramount by law in Hungary. Now, obviously, you can have excellent laws. If nobody obeys them, it doesn't count.
Hmm.
But for me, it was sort of a culture shock that you had to let in the chimney sweep because the chimney sweep would make sure that carbon monoxide levels are low and nobody's going to suffocate in your homestead.
Hmm.
Now, why did we balance this equation like that? We needed to find coefficients in order to make sure that we have the same amount of elements on both sides.
Yes.
Obviously, I would use the rice method, reaction, and every element, and I would make sure we have the same amount on both sides, just like here. Yeah. By the way, I love a touch screen because if I press hard on it, it turns into a laser pointer, so it's
Mhm.
pretty cool. And you had to make sure you had the same amount of atoms on both sides. Now, in real life, other reactions may also occur. If there's not enough oxygen, then soot will build up.
Hmm.
Soot is the black stuff.
Yes.
In Hungarian, we call it korom.
Mhm.
Oftentimes, lots of kids from abroad they don't know this word, despite the fact that they finished high school in English. Why? Because it doesn't really come up often, does it? I mean, people don't really use this expression as often, but rightly so. Not too many people use wood fire uppers or anything of the
Yeah.
sort these days. Yeah. And thank God for that, by the way, because there was widespread fire when chimneys were not built adequately. For example, in London, great fires broke out because chimneys were not made appropriately.
Hmm.
It's just insane. Now, what is the stoichiometry workflow? Well, this is what I usually do. I'm not saying it's the best way, but grams can be converted into moles through molar mass.
Mm-hmm.
Then I'm going to use mole ratios, get the new moles and convert them back into grams.
Mm-hmm.
Or I would just leave them as proportions. I would usually create a huge table. You probably have that in the Telegram channel as well, because I'm certain we did a few examples like that. And it's pretty much like accounting, right? You have a
Yes.
table on with a chemical reaction. What's missing? Oh, I get it from proportions. And
Mm-hmm.
that's about it. I can write up any formula. Should I remember any formula? Should I learn all the formulas that we're supposed to learn? Not really. Using logic and understanding the whole thing, we can write it down mathematically.
Mm-hmm.
What was my biggest mistake when I was your age? Memorizing formulas and not understanding them.
Yes.
When I reversed it, I started understanding things, then I could come up with the formulas.
Mm-hmm.
I could even come up with reaction mechanisms just by understanding the reaction itself.
Okay.
Uh, and you will have that ability too. So first we started understanding and then we derive all the other things from it.
Mm-hmm.
Calculating molar masses, nothing could be simpler, and from amounts you can easily calculate masses, or from masses you can easily calculate moles, and from moles you can also calculate volumes because it depends on the temperature. 1 mole of ideal gas at the appropriate temperature and pressure will have a particular volume. At standard temperature and pressure again, if it's 0 degrees Celsius, 1 atmosphere pressure, it's going to be 22.414, right? Uh, is it? No, it's 22 point and 22 and wait, yes, it's 22.414. Good. And at 25 degrees at room temperature and 1 atmosphere pressure, it will expand. It will be larger. It will be 24.5
Mm-hmm.
liters per mole. So it grows. Now, do ideal gases actually exist?
Mm, yes. No, no, no. They don't.
They could, but under
They
special
don't.
conditions. But in reality, at 25 degrees, no.
Mm-hmm.
I mean, if it's a low enough concentration of gas, yeah, but ideal gases only exist as chemistry problems. Is that an issue for us? Not at all. It's making our lives easier. Should we be concerned about it? Yeah, when real gases come into play, but you will learn that in biophysics. Well then, it's gonna be a whole different story.
Mm-hmm.
But will it be much more difficult? No, no. But you'd be surprised how much Van der Waals played around with gases. God bless his heart. Here's another worked example. Why are we using ammonia so frequently? Well, because for some reason they just love the Haber-Bosch methods in exams, even for medical school. I'm like, what kind of medical application does ammonia have? Yeah, not too many, not too many, but it is a beloved example. And
Uh-huh.
obviously, the Haber-Bosch synthesis has indeed revolutionized chemistry, and it has indeed also revolutionized agriculture. People would have went hungry if it wasn't for Fritz Haber and Robert Bosch. Both of
Mhm.
them excellent men. Yeah. What is seldom talked about is that Fritz Haber. Could you actually come up with a name more German than Fritz Haber?
Probably
It's
not.
like Heinz the Germanstein or something like that. But Fritz Haber was a Jewish guy and he was an avid German patriot. So neither the Nazis or the commies want to commemorate this. And he
Mhm.
did some nasty things. I mean, he did come up with poison gases, like he was able to produce chlorine gas,
Mhm.
and it was used in World War One. And his wife committed suicide because of the poison that his husband has invented, has maimed so many people. So it's a tragedy. It is
Mhm.
indeed a tragedy. Robert Bosch, on the other hand, he was an excellent industrialist.
Mhm.
They asked him, "Do you have so much money that you're able to pay your employees that well?" And he said, "Oh, I have so much money because I pay my employees well." Yeah, true to this day, by the way. Yeah. Bosch to this day appreciates employees and gives them a living wage, and I think that's pretty good.
Hmm.
Yeah, it's a good strategy.
Yes.
Now, how many molecules are there in this much ammonia? Well, let's see, shall we? Well, in 1 mole, we know we have Avogadro's number, so we have to multiply this amount with that amount, and in the end, we get 4.5 times, because it's going to be 6.022 times 10 to the power of 23 molecules. Now, if they would have asked atoms,
Hmm.
it would be it would be 4 times as much, 4 times as much. Do be careful because there are trick questions. And I'm a bitch. I would probably add this value as well if I were to ask atoms. And I would just add the molecules. I'd
Hmm.
not say that if it's molecules or atoms. Or we could ask how many protons are there? Whole different number. Yeah. Or how many electrons are there in this amount of ammonia? That can be a valid question. Or how many neutrons are there, providing that, let's say, a certain percentage of the hydrogens is deuterium.
Hmm.
That would be a special kind of twist, and I would not ask that question in an entrance exam. But yeah, you have to hold the question accountable for what it says. That's the bottom line. What mass corresponds to this amount? It's half a mole of water, so it's around 9 grams. You just look at it and bam, you got it. And the options would probably have moles and other units of measurement. They're asking for mass, so it has to be in grams. Oftentimes we would say it's half a mole, or let's say 9 milliliters, somewhere in that ballpark. Yeah, just to mess with people.
Hmm.
By the way, when the density of water is not given, you have to assume 1 gram per milliliter. Uh, just
Okay.
just a bit of an exam trap thing, and always state what the particles are. Yeah, because
Hmm.
because it can confuse the hell out of people. Also, the Chang book has a lot of good examples like this, but also how to get an A in chemistry from Professor Villani, rather good. Villani looks like a musketeer. He looks
Hmm.
like Porthos, actually. He's just angry all the time for some reason. I don't know why, but yeah. I mean, he used to work at Alta, so it's understandable. Yeah, poor guy. We shouldn't compare grams. We should always compare moles. Moles. Yeah, but certain grams and certain reactions are going to be proportionate to one another because 14 grams is just one nitrogen. Yeah, 6 grams would be all three hydrogens. So just comparing the wrong grams can be a huge issue. So you have to come up with the moles because these compounds are always going to react with certain proportions, and you might have an excess of one. What is an excess? Too much.
Hmm.
Well, if it's too much, then the whole thing will not be consumed 100%. The minor compound will be consumed, and the excess compound will be left over. And
Hmm.
after the reaction has happened, you have to do the math. You have to do the accounting. Well, accounting can be done through spreadsheets, let's face it.
Yes.
And it's best to create a table and hold the whole thing accountable. You are allowed to use a piece of paper for calculations always, and I think that should be rather easy. In the old exam, you won't be presented with such things. This is strictly the written exam, which is going to be in the form of multiple choice questions. So they don't really care about showing your work, they care about choosing the right answer.
Hmm.
But you can't really choose the right answer unless you you do your work.
Hmm.
The written exams are usually taken online with obvious safety precautions. And yeah, with that being said, I know for a fact that, for example, during COVID, Iranian students took screenshots of the question, and yeah, they were able to pass them around. It doesn't matter. There's a huge question bank, so it doesn't really help much. But yeah, if you like, I still have a couple of screenshots like that. I could just extract them and make them public because I think they have already been made public. Um, with that being said, Chinese kids, they bought these questions with money.
Whoa, okay.
Yeah, don't buy anything like that because first of all, there's no guarantee that it has to do anything with it.
Okay.
And second of all, the kind of questions you have are either the same level of difficulty than what you're going to get, or higher level of difficulty than what you're going to get. I
Mhm.
mean, oftentimes if you have, let's say, an 80% with me, you got 110 in the exam, and that is what I want. I put the bar high so you'll be able to jump it. The limiting reagent is going to be the one that isn't consumed completely. And you probably remember we had a little question here with sulfuric acid and magnesium and aluminium from how to get an A in chemistry.
Mhm.
And yeah, you pretty much aced that one. So yeah, it was pretty cool. In this case, it's aluminium, producing aluminium chloride. Oh, the little guy is having a fight with mom. I don't know what the reason is, but he's just going megyek világa. That means he's gonna lock himself in the toilet. I wish he would stop saying that. I mean, something doesn't go his way, and he has a hard time regulating. But little kids do that all the time. Yeah, he's like, that's it.
Mhm.
Yeah. Do you own a water pistol?
Yes. I mean, I did not, but during one of my pool parties, one of my friends left it here, so now I do.
Thank your friend for it. You have a true friend. We own three, and when you pull the trigger, the slide moves. So yeah, later on I'm gonna shoot him. Well, use it in good health, but not randomly and not on your parents, please.
Yeah, of course.
I'm saying this because he does that sometimes. Now, what about aluminium? How much aluminium is that? Well, since we have these amounts in grams, obviously we will have to convert them into moles. Once they're in moles, we know that they react in a proportion of 2 to 3. Proportionality matters. Yes? Which one of them is going to get consumed completely?
The limiting reactant,
The limiting reagent. Very good. We're looking at moles. Who is the limiting reactant?
aluminum. No.
There's 2 moles of aluminium
Yes.
and 1 point. Divide them with one another, and then you'll be able to see.
Mm-mm-mm.
Because if there's a 2 to 3, then both of them get consumed.
Yes.
But here we have a 2 to half of 3, around half, a little bit more than half of 3.
I never quite grasped how to find the limiting reactant in like equations like this. So
Oh,
we're
we're
supposed
supposed to
to
see who
uh-huh.
would consume the other one.
Yes.
AlCl2 and 2 with 3. In this case,
Mm-hmm.
we could divide these two with one another because we can just look at the proportions. Yes,
Okay.
one aluminium consumes one and a half of the other one. Oh wait, that's 0 point. I'm so sorry.
Uh-huh.
Mhm.
Mm-hmm.
So one aluminium would consume 1.5 chlorine.
Yes.
So 0.2 would consume 0.3, right?
Yes. Mm-hmm.
But this is not enough
Oh, okay. So the chlorine is the limiting reactant because of that.
because it's not enough to convert the other one
Okay.
completely. You can just grab one of them and check if it can eat the other one completely. If
Okay.
it can't, well, the other one's the limiting reagent. Easy?
Okay. Yes. Okay, makes sense.
Yay!
So we always
Yeah.
use the number of moles, right?
Yes, we use the number of moles.
Okay.
Very good. Very good. You will find reactions like that in the stoichiometry part
Yes.
of how to get an in chemistry. At the end, I'm going to link you up with the pages and you can practice, and you also have the solutions at the end. That's
Okay.
the great thing about these collections of problems. These appeared in the 90s.
Mm-hmm.
Your dad would probably have done various things just to get his hands on one of these. So would have my mom, to be honest to God. Me, I got a few from Hungary, but I just got the problems, not the solutions. My dad said, you should figure those out yourself. I'm like, God. But I did. Ultimately, I did. And I think that was good parenting because he assumed that I would be lazy. People would tell me the results, but no, that's not the case. Uh, from my perspective as an educator, I've learned that getting that kind of help pretty much helps you avoid mistakes later on.
Mm-hmm.
So I think it's a good idea to give kids the results and a solution because is my solution the ultimate good solution? No, there are many good solutions for it. By the way, if you feel like you need help with math, there's an app called Photo Math.
Yes, yes, I know it.
Okay, I learned it last year, so I'm bragging about it. Yes, Caroline, she showed me that it exists.
Mm-hmm.
Caroline applied to university on the 16th of April, and she was admitted immediately in the oral exam. I was like, no freaking way. When I told this to my Chinese kids, they were like, so, which means the F word. Oh no, the little guy heard it. He knows how to say Cao Nima, which is a thing you're not supposed to say in Chinese. And when he was 2, he learned it from Chinese vendors. They didn't say it to him, but when he said it to the Lees, they couldn't stop laughing. They were like, "Little tiger, you're one of us." Yeah. Here's another one with the limiting reagent. A limiting reagent is the one that gets consumed completely, while the major reagent is the one that doesn't.
Mm-hmm.
That is usually in excess. And oftentimes they will ask you questions like this: how much this or how much that will be left over? Or or what is the composition of the mixture at the end? Why do we learn this? Because in titrations, in pH calculations, or in neutralization reactions, you might have an excess of acid, an excess of base, a salt being formed, a gas being formed, and water being formed at the same time. And
Mm-hmm.
you will have to hold the entire entire change into account. It doesn't matter. You got this and you can do this. Now, we convert the given quantities into moles. What can we tell here? It's a 2 to 2.5 moles. So again, in case number one, the limiting reagent will be chlorine. How much aluminum chloride will be formed? Well, we can calculate it from the limiting reagent because we know that 3 moles are going to make 2. So 0.254 moles are going to make the corresponding amounts. We multiply that with the molar mass, and then we get the mass of aluminum chloride. This is oftentimes a recurring problem. This is from OpenStax chemistry, but we have access to varying websites and books and resources. I usually use the ones that are publicly available. National. Who, no, the final answer oftentimes should be given as such. When you are in an exam hall in the first year, they will expect you to do it like this,
Mm-hmm.
step by step. But if you If you are going to be in the entrance exam, in the oral exam, they will not expect you to do this. In the oral exam, you will get more theoretical and relationship-like questions. Let's say,
Mhm.
how is oxygen partial pressure related to hemoglobin? Something that is borderline physiology, and if you understand those relationships, they will love you for it.
Mhm.
Of course, an excess reagent is the one that isn't used up completely. If it's in an excess, when in our cases it was mainly aluminium, if 5.4 gram reacts with 18 grams of chlorine, which reagent is in excess and how many grams of aluminium are there left in the reaction? First of all, if they told us that aluminium uh, will be left, then obviously it will be an excess and chlorine will be the limiting reagent. It's given that it's a limited reagent. The mole ratio is basically going to give us how many moles of aluminium is that amount of chlorine able to consume completely. The
Mhm.
initial amount in moles is also given, so obviously what is left is going to be the difference between the two. What is left, you can convert it into grams by using the molar mass of metallic aluminium.
Mhm.
Have you ever held a piece of aluminium in your hand?
Aluminum foil, maybe, but
Well, yeah,
uh,
or a can of Coke, that's aluminium too.
yeah.
We have this wonderful green movement that seems to be very nice and it does resonate with a lot of young people. I don't think anybody likes recycling or protecting the environment more than me. However, when they're selling me extra plastic or they're selling me something unsafe, I'm a bit pissed. Aluminium can be recycled as many times as you want, right? What do you
Mhm.
have to do? You melt it down and you got yourself another can. What is more ecologically friendly than that? And it's not plastic. Yeah. And it's an infinite resource. Most of the Earth's crust is made of silicon, oxygen, and aluminium.
Mhm.
So we have enough of it. Yeah. Each age has its own thing, and yeah, when great cultures collapse, the reason is oftentimes the fact that they reach a point where they're unable to make the next big discovery.
Mhm.
Like as the Bronze Age ended and the Iron Age came about, obviously trade collapsed, and they had to find new ways to create wonderful tools, and iron was one of those ways. Yeah, when you have an insight about global history, science, and human nature at the same time, things don't really surprise you anymore. You just smile and wave and carry on with your business, right? Now, there's a common trap. Oftentimes, some may do not subtract grams directly, but we need to convert back to moles, because if we would go with grams directly, we might make a mistake. Now, theoretical yield, have you ever done any chemical synthesis in IB? Don't
Mhm.
get me wrong, it's not holding you accountable, but it's sheer curiosity.
Mhm.
Let's
I
say
don't
you
think so.
precipitated something and then you
I mean,
filtered it,
yes, probably we did.
yeah, and you had a theoretical yield. You put it on a balanced scale, and it turns out the mass wasn't constant. It started reducing as you put the wet little salt on a scale. And then they told you to dry it, and
Mhm.
then you got the actual yield. Yeah.
Mhm.
Now, with that being said, if the reaction occurred at 100% yield, then it would have shown you the predicted maximum amount from the amount of substances you've weighed in. However, in reality, it might not be 22.5 grams, it might be less. What's the reason for that? Why isn't theoretical yield the same as isolated yield? Why
Mm,
is it
it's
usually
based
less?
on, well, theoretical is based on some kind of averages, maybe.
Yes, of course. Theoretical yield has to do with what would have happened if 100% would have reacted and everything went as ideal.
Mm,
Well, practical yield has to do with my clumsiness.
yes, well, practical yield, you can like lose the yield basically from mistakes of measurement,
Yes, yes,
rounding incorrectly.
yes.
And the theoretical is basically
Theoretical means under optimal conditions,
under
everything went
yes, under
well.
optimal conditions. If there was
Yeah,
Mhm.
it's the maximum amount you can get. In
Mhm.
practice, a recrystallization may oftentimes yield you less, or let's say side reactions made a water-soluble compound, it didn't precipitate. Temperature allowed things to occur, or incomplete reactions have occurred.
Mhm.
But usually, isolated yield is less than theoretical yield. If it's a 99.9%, hats off to us, we did really well. Yes?
Mhm.
But usually it's not, unfortunately. Usually it is not.
Mhm.
Now, with that being said, uh, sometimes you might get a measured mass that is higher than the theoretical yield.
Mhm.
That's impossible. That means you either got the Nobel Prize in chemistry, or the more likely thing is that you didn't take something into consideration. You might have solvent left over. There might be impurities, or if you recrystallize things, it may have crystalline water in it. Now, that's why the mass is bigger than expected. But you cannot have an isolated yield larger than the theoretical yield.
Yes.
And we must not confuse it with conversion. Just because, let's say, 100% of my reagents have been converted to 79% product, it doesn't mean I have isolated a 79% yield, because things get lost through side reactions and purification and transfer. And that's an art form on its own.
Uh-huh.
Oftentimes you may lose a little bit through purification, but it's worth it
Mhm.
because in the end you want a pure compound. Yeah. These I think will be useful to you even in IB. And when you're going to have practicals in chemistry, you're going to find it rather fun.
Yeah.
Uh, percent yield usually tells me how bad did I do or how good did I do, because how bad. But usually moderate yield is beyond 50%, good yield, quite efficient, closer to 100. Above 100, we messed up. My mom and dad, uh, they were not doing too well in organic synthesis, apparently, despite the fact that both of them are chemical engineers. I remember them recovering practicals as they told me, and I was like, "Why did you miss a practical?" They looked at each other, blushed. We were busy. I'm like, "Oh my God, I didn't want to know." But the funny thing was that did do silly things with because they had a long synthesis. One step would go after the other. And
Mhm.
Dad, being really smart, he threw away the mother liquor that contained the actual yielded compound. So their fellow lab mates chipped in with compounds so they won't fail the semester. So be careful what you do. And was this mistake unique to my dad? No. So many of my colleagues did that too, because oftentimes young people don't go to practicals prepared. I would always go prepared with a logbook already made, with everything calculated, what to expect, what are we supposed to see, what are the pitfalls. And with that kind of self-discipline, I was able to always create an actual yield that was expected, that was optimal for the reaction. Oftentimes, we would do better than what was recommended by the practical itself, just for being careful and doing it each step the way we were supposed to and at the moment we were supposed to, because there are small details that may be ignored but even not just younger people, even people responsible for the practical. One of them was a name reaction in organic chemistry called Sandmeyer diazotation. They
Mhm.
messed that up completely. And I had a kid at a high school, and he started doing a specialization. He became a chemistry technician first, then a bioengineer. He started the technician part because the extra points allowed him to get into engineering quickly. And the final exam was a Sandmeyer diazotation, and he got an absolutely great yield of 74%. And even the guy responsible for the practical couldn't get that high of a yield. Why was that? Because he was being careful and he understood the chemistry. If you want to produce solids, you need to create something uneven so solids are able to form around something. Then he added the other reagents slowly so it would react with the diazonium salt and add in the thiazide functional group. So it was indeed remarkable, and instead of getting a brown nonsense, he got what was actually written down on paper in the theoretical practical. So yeah, it was great. I'm very proud of Milan. Yeah. How did he achieve that? By doing research. Oftentimes, descriptions may be lagging. Yes, you do your proper homework and your proper research in the field, and you'll be able to do better than expected. Why? Because a lot of people inherit these practicals, and even they themselves don't know every nook and cranny. And you can easily surpass them as a student being interested in the subject.
Mhm.
I mean, in the third year of university, I wrote a book on chemical technology. Basically, I wrote it for myself, and then the dean at the time asked me if she can use it for her book. I said, yeah, fine, go ahead, but I'm going to ask something in return one day. She said, fine. So she became a full professor because that is what was missing from her career. And then anything I asked for was fine by her. I think it was a good deal. It was an excellent deal. Yeah. I mean, we had books on chemical technology in Romanian and in English. We didn't have one in Hungarian. And she couldn't put the effort into it. And we were students, and there were several of us, and we pretty much shared the load. Yeah. So ghostwriting can be lucrative business. Yeah. Now again, aluminium and chlorine, they go at it. They go at it. It's a violent reaction. So is the reaction between sodium and chlorine. It produces a white smoke.
Mhm.
The white smoke itself is table salt. But when these two get together, oh my God, absolutely exothermic. The metal starts burning in the chlorine atmosphere, basically.
Uh-huh.
And the yield can be easily calculated from what was expected and what did we actually get. I mean, if it turned into white smoke, my dude, that's going to go everywhere. By the way, aluminum chloride can be quite
Mhm.
reactive with air as well. So yeah, yeah, it can partially decompose. Yeah. In medical applications, dosing accuracy, solution preparation, clinical chemistry, and in pharmacology, these things are paramount. What do you think? Do we still prepare IVs?
What do you mean, do you still prepare IV? I'm no, there's like already prepared IVs, no?
Exactly, exactly. The reason is that we have overworked and really exhausted staff, and we want to make sure nobody dies because we were overworked and
Good idea.
understaffed. And yeah. It's an extra layer of protection for both patients and workers as well because it's a liability. And
Yes.
if you can get rid of liabilities, well, that's good. Not from a financial or from a legal perspective, but from a moral perspective as well. I mean,
Mhm.
it's really great when something is financially feasible, morally correct, and also lucrative.
Yes.
This is optimal. Now, of course, writing clearly, sometimes calculately. I'm writing this. Why? Because this is where I would mess up
Hmm.
immensely. But in about 5 minutes tops, you can finish any kind of test question. using moles, converting coefficients, limiting reagents, real yields, and extra digits should be kept until the final answer. If partial answers are not asked, keep them as proportions and put them in a final equation so you do not lose any decimals.
Hmm.
Um, Obviously, you might get some oral exam questions as well. Why coefficients in balanced equations represent mole ratios, not gram ratios. These may all come up, and
Hmm.
then you'll be able to add these key ideas. Do you need to memorize any answers? BS, no. Just know the key ideas, and you're going to do rather well. Here's an MCQ style question. This is the kinds you can expect, but you already have a question bank, so I'm pretty sure this is just pure entertainment for you. And of course, you have the key with the explanation. So the rest is just going to be a tad bit of an extra just for you, couple of diagrams, and basically in this case, what we have to do is just do calculations, and the rest is just intended for that bit of private practice. With practice questions such as these, obviously, what's the role of it? To help you understand more, but I think you have a very decent understanding of this set of topics. It may have been useful recap because obviously if you haven't done certain calculations for a while and you said, "Oh, this has always been bugging me. How can I tell who the limiting reagent is?" Well, it's the
Hmm.
guy who gets eaten completely. That's the limiting one. The other
Yes.
one's the big fat one who's still left over. Yeah, it's about who gets to eat whom. If they are able to eat each other and yield a product, then nobody's a limiting reagent. Yeah. Oh
Mhm.
wait. Cheers. I got me some cold tea. Yesterday I just drank a sip of Monster and that was that. So I'm getting well rested. So yeah. Oh wait, I don't know how to turn off the Samovas background, but yeah.
Never mind.
I recently learned that there was a cocktail that contained iced tea and lemonade,
Okay.
and you're supposed to put them together and it turns into something amazing.
Okay.
It was named after some guy. I completely forgot, but I'm going to send it to you. I'm going to send it to you because whenever you're having lunch with anyone, yeah, and they're like, "Oh, I'll just have a water. I will have a Pepsi," and you go like, you tell them to make this cocktail, and everyone's going to be like, "What's that?" And everyone will want it, and they will remember you for it. I'll just look it up. I found it at random, but yeah, it's amazing. I mean, imagine getting tea with lemonade.
Okay, tea with lemonade. Sounds.
Yeah, yeah. The next part is also going to be through the calculations.
Hmm.
But as you can see, it has a lot of slides. Now, just because it has a lot of slides, it doesn't mean it's a lot. It
Okay.
just contains a lot of examples to help
Hmm.
you exercise.
Yes.
Because obviously, there are a few concentrations that are going to be necessary for us as future medical professionals.
Yes.
But it doesn't necessarily mean that, oh my God, I have to study molarity, molality, percents, or parts per million over 70 slides. No, we just get examples of what to expect. If I would drop a little sugar into water,
Hmm.
around the lump of sugar, I would probably have a higher concentration. But as more and more I move away from that lump of sugar,
Hmm.
going to be less and less concentrated. What can I do to make the entire solution homogeneous? Mm, Since we're talking about tea, well, I don't know about others, but I do like a cube of sugar with my tea. I know it's a sacrilege, but
Stirring? You have to make use the stir. No, that doesn't make sense.
no, no, no. Actually, it is. Stir it. Yeah,
Yes. Okay.
yeah, yeah. Dude, say what you mean. Ah,
Oh, oops.
it, it is stirring. Oh my God, I'm so glad you worked up the courage to say it. Of course, then you're mechanically making it homogeneous.
Hmm.
If you have all the time in the world, obviously it will occur on its own through passive diffusion. But until then, well, you got to do this. Hydration occurs differently. Yeah, towards sodium, oxygen's negative sides are going to be more attracted to towards chlorine. The more positive side of water will be attracted to, but both ions will be hydrated. And so draws water, but not because it has a water-sucking effect. It draws water because it wants to even out the concentration of water and salt. Why do solutions matter? You probably remember the little story from Berkeley, how they almost killed a few graduates by accident, by being irresponsible and not cut out to do their job. Nowadays, quite a few cases in which people are being hired for their perceived appearance in order to seem politically correct.
Were there what?
Well, when people are being hired because of their appearance, just to seem
Uh,
politically
yeah.
correct, just to seem inclusive. And this really hurts people from the early 2000s who got there because they're good. And people nowadays may question themselves, am I really good or is it because the way I look? Yeah, and oftentimes it's the case, unfortunately. And oftentimes, people who are expert manipulators, they're going to say, "Oh, so you're defending the indefensible, and that's why you're against immorality." No, no, that's double talk. That was a political thing that commies often did, but any kind of political group does that. I think it's bad. I think it's inhumane, and I think it's against progress.
Hmm.
If you want the best of the best to get there, you teach everyone the same way, you expect the same things, and that's about it. So don't listen to the news or anything like that when they say, oh, these people are this and that. I mean, sometimes it may occur, but in this day and age, I think it's impossible,
Hmm.
um, especially in an environment where excellence is the driving force, not who's more well connected. If they give you the wrong IV, it doesn't matter what color you were or what color they were. Basically, you might die. So you have to be well prepped. And by the way, my students, it doesn't matter what race, religion, or other background they are. Their degree is basically a letter of recommendation at the same time in
Hmm.
many countries, in many places, and in many hospitals. And they don't really have a hard time finding a job, providing they will take the job what is offered. I mean, when you start out somewhere, you got to start out somewhere. But sometimes it's just a diving board, good, but you got to start out somewhere.
Yes.
Yeah. And nowadays it's quite seldom that people retire from their first job.
Hmm. Yeah.
Why? Because you'll be job hopping in order to get better offers, right?
Hmm.
And you have to, and you have to, and thank God you have the opportunity to. So.
Yes.
Yeah, don't listen to the bad kind of crowd. Listen to people who are good at what they do and they're recognized for it. I have a lot of colleagues like that.
Hmm.
It doesn't matter who's in power, they are being asked for their opinion. Why? Because they're good.
Hmm.
There's no way around them.
Yes.
And I appreciate those kinds of people. And their opinion doesn't really matter on who's in power and what's the incentive. They're just going to say the truth as it is because there's nothing else they can do because
Hmm.
it's about human lives and about human lives you can't really ignore the truth or it's going to have really powerful consequences.
Yeah.
Blood electrolytes in homeostasis absolutely paramount. Sodium, potassium, chlorine, calcium. Wink, wink.
Hmm.
Exclamation mark. Your mom knows best, dude. No, seriously, when immune functions flare up, calcium is useful. I'm not saying it's going to have antihistamine effects because it will not. But does it help? It doesn't do bad. Yeah.
Hmm.
I also have these little satchels of potassium and magnesium. Why? The average Hungarian underconsumes potassium, and I'm as average as you can get. So, yeah, or sometimes even below average. With glucose levels, you see the American unit. We use the same unit in Romania, milligrams over deciliter. Do you use the same units in your country as well?
Yes,
Or
I
do
think
you, yeah,
milligram.
yeah,
I
I don't know. In
think
Hungary,
so.
they go with millimoles. I think it's because of physiology books. Because in America, physiology books are going to go with 5 millimoles per liter. It means
Okay.
the same thing. Yeah, it's just a different unit.
Mm-hmm.
But it can be confusing. It can be confusing, especially when someone's under stress. Oof. Yes. So that's why solutions matter and why units matter.
Mm-hmm.
You have to be able to convert from one unit to the other. In lab tests, they're going to measure all of these, and even bicarbonate and partial pressures, of course, of oxygen and carbon dioxide.
Mm-hmm.
Those are going to have the medical implications. Dissolution and absorption, very important. I've told you about liposomes yesterday. Liposomal compounds get absorbed easier into the lipid bilayer.
Mm-hmm.
Sometimes this is what we want. Yeah, I want high levels of vitamin C, and then I ask, why? Well, because it has good anti-cold effects.
Mm-hmm.
No, no. Just take it slow and listen to medical recommendations, not just to marketing alone.
Okay.
Yeah. People have really good marketing in various places, and I love that. I wish I would have that good of a marketing, because yeah, that always works. But the bottom line is, actions speak louder than wonderful narratives. What is the actual effect? What the studies suggest? What's the data? What's the data? That's my favorite question. Yeah.
Mm-hmm.
So, salt dissolves easily in water, it dissolves on its own. When we're going to talk about entropy, you're going to understand it even better. Why? And if you add a little salt to ice, the temperature will drop to minus 22.
Yes.
So, just saying, if you were to make ice cream or any kind of frozen treat, go ahead. And we are aqueous solutions, whether we like it or not. Certain compounds are hydrophilic. There might be H2O pluses formed in the water as well. Urine is mostly made of water. Well, our kidneys try to keep back as much water as necessary
Mm-hmm.
because we're grounded. We're no longer living in water. Hence, our kidneys need to work overtime. With fishes and especially sharks, that's a whole different story.
Mm-hmm.
Shark meat is really weird. I think only
Shark
Icelandic
meat.
shark meat, yeah.
People
Icelandic
actually eat
people
that.
ferment it. Yeah, some people eat it, but oof, they need to ferment it, and it smells a particular way, and it's a test of bravery to eat it nowadays. Back in the day, for Icelandic people, it was a necessity. They eat it as our culture eats bread.
Whoa, okay.
Yeah, it doesn't taste that great. It's English people would say it's an acquired taste. When some kind of ethnic food tastes really bad,
Uh-huh.
an English person would not say, "Oh, this tastes real bad." They would go, "Well, it appears it's an acquired taste." Yeah, or they're polite because an American would stand up to you and ask, "Did you just fart?" An English person, it appears your dinner disagreed with you. I love this kind of communication because it can be rather truthful, but not as offensive, not as hurtful, not as nailing you to the wall. Yeah,
Uh-huh.
it still allows you room to breathe and recover from it.
Mm-hmm.
But I love the fact that, for example, Americans are geniuses at being direct and
Mm-hmm.
asking for the no BS numbers. I like that too. Yeah. Bottom line, interstitial fluid contains water, cells contain water, cytosol contains water. Your kidneys are trying to hold back as much water as necessary. Obviously, this is why oftentimes we're being advised to drink up, but let's not go into excesses. Let's not get into water poisoning. However, a lot of elderly people, they don't necessarily feel thirsty. So, yeah, you have to give them a schedule or give them a special bottle that tells them to drink up. And
Mm-hmm.
they're going to feel well, and oftentimes it's a good idea to supplement them with B vitamins as well. Why does concentration matter? Well, first of all, what does it mean? How much do I have in a certain amount of solution of the useful or interesting compound? Oftentimes we go with just simple sodium chloride.
Mm-hmm.
Molarity tells me how many moles do I have in a liter. Molality, how many moles in a kilogram of solvent. Oftentimes, if all I have is a balance scale, that works wonderfully. Mass percent, what mass of the solution is my solute?
Mm-hmm.
Volume percent works with alcohol and also with other things. I think they also use volume percent in milk, but I'm not sure. Might be mass percent. But you have 3% milk, 1.5, 0.1, 2.5%. I don't know why these are there. I think it has to do with how much fat does that particular milk
Yes.
have.
Mm-hmm.
That's good. I mean, usually bodybuilders go with the 0.1% because it's high protein, low fat, low calories. It doesn't taste like much, but yeah, it can be really good. Yeah. Nowadays we have a culture of protein. Yeah, but an extreme excess can do a number on the kidneys, so everything should be consumed in a balanced way. Mass over volume percent. How many grams do I have in a certain volume of solution?
Mm-hmm.
Or ppm, in milligrams of solute per 1 million particles. Why milligrams? Because at that very low concentration, for most compounds, it's going to be milligrams per million.
Mm-hmm.
It's actually parts per million, but at such a low concentration, it doesn't matter anymore. 10 to the minus 6, 1 divided by a million. That's such an insanely small number that it's really difficult for us to grasp. But obviously, a lot of heavy metals, if they're present in parts per million amounts, and in excessive parts per million amounts, they can be dangerous to the human body. I mean, the optimal is zero. Is it possible for anything to be zero? It can be just
No.
beyond detection limits. Yes. I mean, it could be zero. Yeah, it could be. But we have such an interconnected world that I'm not sure. Uh,
Mm-hmm.
there is no place on Earth that would be lead free because we used a catalyst called tetraethyl lead and it got everywhere. Now, what does the industry do in the US? They're claiming to be ecologically this and that. I mean, don't get me wrong. I don't think the energy industry is bad, not necessarily. I mean, not at all. Like any industry is trying to make a profit, but its roots are rooted in immoral and wrong kind of behavior. I have a lot of friends working in the energy industry. Some went from the oil industry to nuclear, and the bottom line is it's what runs our civilization. There's no way around it, and it's beneficial. Bottom line, let's face it. But what I've seen from people from Greenpeace, they bring about solutions that don't work, and they just repeat a narrative. I haven't seen an engineer actually work for Greenpeace and tell them, look, guys, I have found a better solution. Let's use this one instead of that one because it's far less polluting and more efficient.
Mm-hmm.
They just go on a vibe, and I don't like vibes. I like the truth. So always ask for evidence.
Yeah.
And if you're being labeled for asking for evidence, that means it's a cult. It's not scientific fact. And I don't know about others, but I don't want to be part of a cult. Milligrams of solute per milliliter of solution in drug dosing, in injections, this might be very important. Millimoles of a liter. When you have a really powerful medication, it's going to be millimoles of a liter. And you have to convert milligrams per milliliter to milligrams per liter oftentimes, which is obviously 5 milligrams per milliliter is going to be 5 grams in a liter or 5,000 milligrams in a liter, which is a powerful amount. It's like the dosage of creatine. Around 5 grams of creatine can be easily diluted in around half a liter of water. If the water is room temperature, the colder the water is, the less likely creatine will dissolve in it. And
Hmm.
what I've seen, a lot of kids complain about creatine not dissolving properly. Yeah, because you need the appropriate water for it. If it's hot water, it might damage it beyond 60 degrees, so you're not going to add it to your cocoa, coffee, or tea.
Hmm.
If it's room temperature water, it will dissolve like powdered sugar, and you'll be able to drink up. I mean, let's face it, someone who does bodybuilding, they can easily drink half a liter of anything.
Yes.
So it won't be an issue. And to be honest to God, any creatine monohydrate can be easily consumed like that.
Hmm.
Excessive consumption may upset one's stomach, so it's not worth the gamble. However, a proper dosage will keep your tired brain working with optimum efficiency as well. I mean, if you take, let's say, 23 grams in 24 hours and you pull an all-nighter and you keep consuming creatine with your drinking water, you'll be able to yield better results tired than you were able to yield well rested without creatine.
Okay.
Why? It just helps you use ATP more efficiently, and
Hmm.
it also helps your brain function better, not just your muscles.
Hmm.
Now, be warned, I mean, obviously, I know lots of young women are self-conscious about their weight. If you take creatine, it may increase your body weight, but not your body fat, not to circumference or anything. It just hydrates your muscles a little better. That's it.
Hmm.
Not an edema, not weight gain, as in fat gain. It just helps your body work with better efficiency. And creatine is naturally available in beef, in meat, but oftentimes people are struggling to eat that much meat. Because many people are like, "Oof, how the hell am I supposed to eat 1.5 kilo steak?" I mean, I know people who are able to do it. I don't want to point fingers, but it's not easy.
Hmm.
Yes. Concentrated solution has a lot of solute per volume. A more dilute solution, less solute per volume.
Hmm.
Which is, if I increase volume, it pretty much decreases concentration. These things go hand in hand. Oh, I also have an infographic on this. No, it's mainly pH and this. So when we're going to do pH next week, we're going to go just with pH, and we might be doing pH for a while because there's a lot of calculations, and it is the most difficult topic in chemistry, mind you. So we will do our very best, and obviously the hydrogens are going to be more attracted to chlorine, oxygen is more attracted to sodium. Sometimes it's visible, sometimes it's not. I stopped being angry at the language model, but in the dissolution process, I think it's spot on, and that's what matters.
Hmm.
Water is polar, so like dissolves like. Sodium chloride will be dissolved in water, despite the fact that it's thermodynamically endothermic. It will still happen because kinetically it's favored. It destroys the crystal lattice and increases the motility, the movability of ions, and it's entropically favored.
Hmm.
So salt dissolves this by all means. An electrolyte will conduct electric current through ion conduction. A non-electrolyte will not. However, mind you, to turgidity, glucose may contribute as well because the turgidity of a cell or a solution will also be influenced by any kind of solute inside. So yeah, I think you love Powerade, right?
I don't think I ever drank it actually.
You never drank Powerade.
I,
Oh my
I
God, I'm in shock.
I don't think so actually.
Oh my. Well, you should definitely try Blue Powerade. I don't think you're a Semmelweis student until you tried Blue Powerade. Blue Powerade in your baggie. I'm so ashamed now. Because I see all of my kids carrying a blue Powerade, usually on Monday, and then they will refill it with their own isotonic solutions and whatnot. It's not easy being a student. I mean, you have these 15-minute breaks, and in that break, you have to use the bathroom, you have to eat, and you have to drink up. So,
Yeah.
yeah, it's not that easy. However, Powerade and all rehydration solutions have a little bit of glucose as well. That also contributes to tonicity and it also contributes to osmolarity. Despite the fact that it's a non-electrolyte, it does carry water and it does help people who are severely dehydrated because oftentimes they're unable to keep down food. So,
Hmm.
glucose, salt, potassium, sodium, magnesium and calcium in smaller amounts, but sodium is the most important part. They will help someone get better from severe dehydration. That, as we established, comes from diarrhea, vomiting, blood loss, excessive sweating, overworking, fever. What else would do? Yeah, yeah. Or people who just forget to drink, elderly people.
Hmm.
We had an elderly woman collapse on the market because she forgot to drink. She had incontinence. So
Oh.
she said, "Oh, if I'm not drinking, I'm not going to piss myself, so it's going to be great." And no, no.
Hmm.
And you know what? She should piss herself 10 times a day, just not die. Yeah? And by the way, these can be treated in various ways, and but I understand the shame that goes with it. Still, yeah, she's
Hmm.
better now. She's doing well now, but yeah, non-electrolytes do not form ions, but they do contribute to osmolarity oftentimes. How do
Hmm.
we calculate molarity? Well, we calculate how many moles are there in a liter. If we have the volume, in how much volume did we dissolve a certain mass, the mass is converted into moles, and then we have the chemist's measuring unit, molarity. Various concentrations can be converted into one another, and obviously ion concentration may have to do with formula, unit, molarity, and the coefficient. If we're looking for the amount of chlorine from calcium chloride, it's going to be more than in the case of sodium chloride due to dissociation. Now,
Hmm.
if you have an Eastern European or Armenian or Soviet bloc teacher, they're going to use dissociation for both ionic and molecular compounds. In proper English terminology, ionization has to do with molecular compounds and dissociation with solid salts.
Hmm.
Parentheses, but if anybody asks, that's the correct way. I'm afraid that older colleagues might still use dissociation from Hungarian terminology, and even though they do teach in the English line of study, they might not be familiar with it if they haven't gone through a proper English language
Hmm.
educational system, such as you yourself did.
Hmm.
Molarity is moles per liter is the chemist's measuring unit. Why? Because of stoichiometry. Yeah, if I'm trying to find out how much of this do I have, well, we have to react it with a certain volume of the other thing and then look at the results. Why does this flask have a ring on it? Is it getting married?
No, because it's the graduation mark.
Perfect. And it should also denote the temperature at which this is. Oh, it does. It's 20 degrees. Yes.
Yeah.
So proud of you, man. Now, because a lot of my first year and second year students have no idea. They're like, and yeah, I'm just getting the responses. So, yay!
Mhm.
This is oftentimes called a physiological saline solution. Why? Because of its osmolarity is equal with the osmolarity of our insides. And
Mhm.
also it hydrates us through water and through sodium and chlorine being given to us. I had a friend, she said she's having a panic attack and her right arm is paralyzed. We took her to the ER. She got a saline solution from an IV and she could move her arm again.
Yay.
Um, yeah, it was psychosomatic. She was under a lot of pressure, so it was exam sessions and I guess she just needed a way to get out of the environment she was in because it was overly stressful and overwhelming for her.
Hmm.
Great person, great mother, great professional. I can just say the most amazing things about her. But these things have happened to her. Should she be ashamed of it? No, no, because these things sometimes happen, and it's fine. It's all right. Now, sodium chloride dissociates completely in water, so obviously the concentration of both chlorine and sodium are going to be equal, and they're going to contribute to osmolarity the same
Hmm.
way. And clinical labels require chemistry conversions before just interpretation alone. So
Yes.
oftentimes osmolarity will be added as well. And isosmotic is going to mean an osmolarity between 290 and around 310 milliosmoles per liter. We're going
Hmm.
to talk about osmolarity in greater detail. Glucose osmolarity obviously depends on the concentration, and that's a bit of a messed up structure right there. But we know the structure of glucose. Obviously, it's a hexose. It dissolves as a molecule, not as an ion.
Hmm.
And from mass, we can easily convert to molarity. We just convert to moles. That's about it. And we have a lot of solved problems here. You can just simply go over these because I don't think they pose a challenge to you at all. And from formula, you can easily calculate the amount from which you can calculate the moles from which you are able to calculate molarity.
Hmm.
How do we prepare a standard? I think we already did this. It should have a cap, so it doesn't really fall out, but otherwise, yeah, that's the way we do it. We measure things, we dissolve things, then we make sure everything's dissolved. Then, as you said, the graduation mark is well important. The solution's volume is set after at dissolving before the calibration mark. Then we just add water dropwise to reach the calibration mark. Often my students use a spritz flask and they're like, "Sir, it's too much." And I'm like, "Don't worry, let's redo it. Add the final amount in droplets, and then it will be perfect." And it is, and it is. They're smart kids, but imagine the following: it's their first time in a chemistry lab.
Hmm.
Obviously, you're going to fail a lot of times, but through experience, obviously, I was able to cushion their fall and just tell them beforehand where did I mess these things up? Yeah, there are a few traps. Obviously, you have to convert everything into the appropriate unit of measurement. These all come from my own failures. Uh, V1 times C1 equals to V2 times C2. So you're able to easily calculate the amount of water that needs to be given to a solution to get the new dilution. We can easily derive this from the second volume, the second concentration, because these are all proportionate because the amount of substance is constant through dilution. See, the only thing that changes is the volume. As the volume becomes bigger, then the molarity becomes smaller. Why? Because I added water to it, it became more diluted. Yeah, imagine adding a spoonful of sugar to a cup of water, tasting it rather sweet. If you dilute it to a liter, immediately it becomes far more pleasant. Heck, you add a lemon wedge to it, it becomes something quite tolerable. Silk solution is prepared at a low concentration, and from that, we prepare working solutions in a laboratory for titration and for other determinations. Because from stoichiometry, we're able to determine basically how much of an unknown substance we've got. A simple dilution means if I have 25 mils of a 2 molar that has an increased volume tenfold, well, obviously that will also reduce the concentration tenfold because they're proportionate to one another, right?
Hmm. Yes.
Oftentimes you're going to use a pipette or a split flask. The main thing, make sure the meniscus is at the mark. Yep. Otherwise, fine. This is again just for practicals. I'm using these slides, by the way, for practicals because it's necessary. Now, repeated dilution is obviously going to reduce the solute particles, and oftentimes this is used for calibration. Yeah. Why do we calibrate? Well, in order to make sure that the measured parameter is proportionate to the concentration, because we know the initial concentration, and through measurements we will be able to make an appropriate calibration. And if it's linear enough, then we can use it for determinations. If it's not, bad news, old boy. It cannot be used for analytical purposes. Back to the old drawing board, find a new method, find a new parameter. With serial dilutions, uh, obviously, you're going to get more and more diluted solutions. And as you can see, the appearance changes to almost transparent. Now, if I would use spectrophotometry for this, the initial solution might be too concentrated. The final solution might be too diluted in order to be able to be used. However, anything in between, when color is proportionate to concentration, can be determined to determine can be used to determine concentration. This applies to any kind of dye. We did this with red wine. If red wine is too colorful, you have to dilute it quite a few times, and then you're able to tell what quality its color is.
Hmm.
And we haven't really talked about anything else from it yet, but it is one of the first steps in determining red wine quality. A calibration curve can be made from this, and oftentimes calibration, well, if it's linear, the linear part of the curve can be indeed used for determining concentrations from absorbances. That device there, that was my livelihood for more than 3 years. And it's great, by the way. Now, obviously, we have to use the final volume, keep matching units, and dilute concentration, not pH labels, because the two don't go hand in hand. And when we're going to do pH, I have an infographic that puts the whole thing into place, and God digits. Now, a few exercises for dilutions. I'm just going to skip over it because you can probably do this in your own time. From mass percent, I have 5 grams, and I complete the solution to 100 grams. That means I have a 5% solution. But if I add 5 grams of sodium chloride to 100 grams of water, that will reduce the mass percent to less,
Hmm.
because we compare to the mass of the solution.
Yes.
You probably remember the trick here. Uh, if I dilute 5 grams of sodium chloride in 100 grams of water, what mass percentage do I get? And most of my students are going to go with 5%. Many of them are just going to keep quiet. What if I mess up? And then there's always a Japanese kid who goes like 4.7% approximately. I'm like, yeah, baby. It's true. Or really smart because they go like less than 5% because I'm lazy to do the math. But yes, it's less than 5%. That's the bottom line. If you have a calculator or if you're good at math, obviously you're going to be able to tell. Volume percent, how many mils do I have in the entire amount? This applies to palinka and alcohol. Yes, if you were a high schooler 10 years ago, then you knew a wonderful Hungarian writer by the name of Bartosz Csaba István, an absolutely insane human being, the most renowned alcoholic in Hungary. Um, what can I say? He's no longer an alcoholic. He had Monster, and his life turned around. But yeah, he's a bloody shame. Yes, he's pretty much the shame of Hungary. Um, Still, people love him. I love him too. I mean, when he was an alcoholic, I would buy him a bottle of wine because I knew he liked it, and that was it. But the smell alone, dude. Yeah. And I told my kids, look, you would really love it if someone would look at you in a way Bartosz looks at a bottle of alcohol. And they were like, yeah, yeah, yeah. Definitely. Now with saline solution, obviously that's 0.9% means 0.9 grams in 100 ml. That is the physiological solution. This is mass per volume. So with ethanol, obviously, dosage plays an important role. At this point, usually I bring about my PhD supervisor, Tony. He was 7 kilos in the 80s, and how much was he allowed to drink? Well, nowadays, zero. So it's easy. Again, a lot of solved problems and medical solutions. ppm, I think you did in IB when you talked about pollution, both in chemistry and in biology, right?
Hmm.
There was an extra reading at the end of the chapter.
Hmm.
You used the Cambridge book or the Oxford one, or a
Both,
different one?
both at sometimes both.
Both. That's good. That's good. I would do the same. If you like, I can send you IB resources when you need some.
Okay.
No,
I mean, you already sent me some, I think. Yeah,
I
you
think
did.
it's uploaded. IB
Yeah,
chemistry is
you did. You
uploaded.
did.
Yeah, that pretty much shows you what to expect at each test in Chem. In bio, I don't have that many because I really didn't teach IB bio yet. I'm more trained in chem, but yeah, fluoride in drinking water is necessary. We have double this amount fluoride in our own drinking water. It's too much. Lead, thank God it's been filtered out. And yeah, I also added a water filter to the shower. My wife's skin and hair has improved immensely, so thank you. I think it was one of our first lessons when you told me, well, you could just add a water filter. I'm like,
Yes. Uh-huh.
yes, and it's a few pennies to the dollar if you think about it. It's worth it. It's definitely worth it. And I'm gonna add one to the washing machine. Thanks. Now ppm is 0%. Yeah, let's face it. ppb is 0%. It's micrograms of solute per liter of solution. And in poison, even ppms can indeed matter. Oftentimes, if it's a really dilute aqueous solution, then 1 ppm can be really, really close to 1 milligram in a liter. Yeah, but that can be too that can be too much as well. Excessive fluoride can be toxic. And of course, in clinical conversions, milligrams per liter to millimoles, this plays an important role in sodium and blood glucose levels. Blood glucose levels from Hungarian units to our own unit. Yeah, sometimes we have to do that. We're going to use molar mass, which is around 180 in the case of glucose. So yeah, it's going to be fairly easy. 5.6 millimoles per liter is going to be around 100 milligrams per deciliter. So not that big of a deal. Yeah, in the case of glucose, yeah, it's gonna be 96 actually. I just went around 100. I didn't do the calculation. I just did an approximation. The same thing applies to sodium, potassium, chloride, and calcium as well. Now, there's a bit of an oddity. We use millimoles in Romania and in Hungary. Oftentimes, they're gonna go with milligrams. It is what it is. What can you do? But yeah, yeah, but yeah, millimoles is much more universal. Yes, and I think that's good. Drugs are oftentimes administered as such, not the bad kind, the good kind. Couple of exam traps, obviously, molality. Again, if all I have is a balance scale, it's perfect. And for osmolarities as well. And it uses solvent masses because it doesn't really need to take into account temperature because varying temperatures, molarity may change due to the volume being measured. Yes, molality from mass you can easily calculate it with of course glucose. Again, a couple of exercises. Temperature because of expansion may influence things. And of course, solubility changes through temperature. Next week, we're going to do solubility first. And colligative properties. Colligative properties change because of chemical identity as well. Vapor pressure is going to lower, boiling point is going to elevate, freezing point is going to be depressed. Osmotic pressure is going to change, and that's very important when we're trying to make things isotonic. The Van Hoff factor is I. It's a little number. It's a particle multiplier. Virtually, we're going to take the ideal one. When you look at the books, all the chemistry books, you'll see that in reality, sodium chloride has a Van Hoff factor of 1.9. We're going to assume 2. If it's not given, then obviously that is the number we're going to assume. In the case of glucose, it's 1. In the case of sodium chloride, it's 2. So obviously, you're going to have more particles. And this contributes to osmolarity. Isotonic solutions are these all rehydration drinks and also the blue drink, the Powerade drink. People go mad over Powerade. They just love Powerade. Mountain Blast plus vitamin B6 seems to be the favorite for my children. Even my son loves it. Whenever it's really hot outside and whenever there's issues like diarrhea, vomiting, you name it, he has it. We give him this blue drink and he recovers rather quickly. Yes.
Mhm.
Now, when there's a more concentrated place, obviously water will be drawn in that direction. A solute is going to draw water. We're trying to keep things isotonic. If something's hypertonic, obviously it's going to dry out the cells. If it's hypertonic, it's going to make them burst via osmosis. Oftentimes, a Van Hoff factor is a determining factor of osmolarity. Basically, Van Hoff
So
factor
one
times
whole factor?
the little I. Basically, how many particles does this bugger produce? Yeah, glucose, 1 for 1 mole. Sodium chloride, 2 for 1 mole. That's the Van Hoff number.
Hmm.
It's the little I.
Okay.
If you want to take osmolarity, obviously, in the case of calcium chloride, it's going to be 3 particles per 1 mole. So it's going to be the osmolarity of 1 mole of calcium chloride is going to be 3 osmoles per liter,
Hmm.
or 3 times the amount because of the particles it's able to produce. However, despite the fact that glucose is not an electrolyte, it's still osmotically active. That was the message of today's lecture, and it's particles per liter. It's particles per liter. Both contribute to a physiological solution and to osmolarity. And if you add these together, all of these, yeah, it's going to be 0.300 osmoles per liter, which is exactly isotonic with our own blood.
Okay.
Hey, and of course, osmolarity and molarity, they're related through the little I, through the one Hoof factor. Basically, how many ions will it produce? Obviously, this is under ideal conditions, but
Hmm.
unless they give you the Van Hoff factor, you can assume it to be equal to the number of particles that thingy is able to produce in water. Okay,
Hmm. Hmm.
that's all. And yes, a couple of osmolarity problems just to keep you in shape. What's isotonic, hypertonic, hypertonic? We did in biology at the beginning of the year. Why IV fluid is the way it is. We've said this already. Plasma has an osmolarity that comes from many things. And urine concentration in the kidneys also changes depending on where that is. But the rest is just interesting things from physio and basically a bit of a toolbox that helps you prep. So I'm not going to go into great details with that one. I will leave it for self-study if it's okay by you.